Welcome to 3 Steps to Sketch. Today we'll look at a basic secant graph, so one that's unshifted. We're going to graph y equals -3 secant of pi over 2x. So here's our template and our equation with our grid. So notice that our equation is in that general form, y equals a secant of bx. We don't have any shifting going on here. So we start by finding our companion equation and its essential information. So essentially we're going to graph this companion equation so that we can get to our secant graph. Our companion equation simply replaces the secant with cosine. It's reciprocal. Now, if you have not familiarized yourself with how to graph cosine equations, see the links in the video description. Make sure you check that out before, because it'll make this process so much easier. It relies very heavily on your existing knowledge of cosine graphs. All right, so our companion equation will be y equals -3 cosine of pi over 2x. Now we'll analyze a little bit. Our a is -3. So the absolute value of that will be 3. That tells us our amplitude of cosine, which is distance from midline to either max or min. We also notice that we have a negative, which means our original cosine pattern is going to be flipped. So we'll put a star at step 2 so that we can remember that, and we'll discuss that in more detail when we get there. Okay, and now b is our coefficient of x, so that'll be pi over 2. It tells us that we should have pi over 2 cycles happening between 0 and 2 pi. So a little bit more than 1 cycle in that space, 3.14 divided by 2. And it also helps us calculate the period. We do that using 2 pi over b. So we have 2 pi divided by a fraction. So let's multiply by the reciprocal. So that turns into 2 pi times 2 over pi. And we see that our period will be 4. And remember, period is just the length of a horizontal cycle. So now that we have that basic information organized, let's choose how to label our axes. We're very intentional about our horizontal scale label, our design here. Take the period and divide by 4. So 4 divided by 4 will be 1. And we do this so that when we plot the companion pattern in step 2, each of our key pattern points will align with these horizontal tick marks. And that just makes for much easier graphing and a nice neat graph as well. All right, for our vertical scale, 1 will usually work great. Look at A, and we see that should work well with 3, counting by ones. So let's take a moment and label our axes. Nice and easy, just counting 1, 2, 3, 4, 5, 6, 7. We'll do that in the other direction as well. So we're counting by the same unit for both axes, which is kind of nice. So label the vertical counting by ones as well. -1, -2, -3, -4. One of our favorite labels when you have pi as a term in your B term. So now that we have everything organized and set up, we are almost ready to move on to plotting our companion pattern and getting our graph. Before we do that, I like to go ahead and find the asymptote generating equation. So these will be our asymptotes for our secant graph. I'll go into detail about this in some videos that I post later on. So look for those if you're interested in knowing more about finding asymptotes of secant graphs. But for now, know that you just take the inputs of the secant function, so that's pi over 2x, and set them equal to pi over 2 plus pi k. And we set it equal to that because those are the original asymptotes of the parent secant graph. So that's of y equals secant x. And it does relate to where the zeros are for the cosine function, because when you try to take a reciprocal of a 0, of course you come up with an undefined value, and that creates a vertical asymptote. But again, more on that in a later video. For now, to find this asymptotes equation, you again take the inputs of the secant function and set them equal to the parent asymptotes, pi over 2 plus pi k. Then you simply solve for x. So to do that, we'll multiply the whole equation by 2 over pi, or dividing by pi over 2 accomplishes the same thing. So we're multiplying by 2 over pi. And let's write the result in our blank here. So we'll have x equals, you ended up with 2 pi over 2 pi, so that cancels to 1. And then we have plus, the pi's canceled in the second term, so we have just plus 2k. And you can use this asymptotes equation substituting in different values for k. K is simply an integer, it's a placeholder. So depending on what value for k you substitute in, you'll get a different asymptote along your secant graph. Play around with it a little bit. K is 0 gives you an asymptote at x equals 1, whereas k is 1 gives you an asymptote at x equals 3. Let k be -1, you see that you should have an asymptote at x equals -1. So it's really nice. I like to go ahead and find this asymptotes equation at the beginning when I'm still doing all my analysis so that I can use it when I check my final equation and graph at the end. All right, so now we're ready to move to step 2 where we plot our companion pattern. We're essentially graphing that cosine companion equation. One quick thing to notice, we have this star, and I like to put this here because we have that negative sign out front. So we know our basic cosine pattern is just going to be reflected over the x-axis. So our companion pattern will be minimum, x-intercept, maximum, x-intercept, and then repeat. Remember that you should plot this companion pattern lightly because this is not our final graph. It's simply our companion equation that we'll use to find the reciprocal graph. All right, so companion pattern for cosine is going to start with a minimum here. And to find the y-coordinate of this minimum, start on the y-axis, simply look at A. A is -3. So our first point, our minimum, is going to be 0, -3. Okay, our x-intercept should happen at our first horizontal tick mark. That goes back to why we chose our horizontal scale, how we did. Our maximum will happen at the next horizontal tick mark, and the y-coordinate is simply the opposite value of A. All right, then we have another x-intercept here at 3, and then we would start a repeat of the next cycle. So you can see that this would be the graph if you were actually trying to graph y equals -3 cosine of pi over 2x. That's what you have right here. And now we're ready for the fun part, step 3, where we recip, sketch, and repeat. So we're not taking literal reciprocals anymore. You can do that with a very basic secant graph if it doesn't have a term for A other than 1. But here we know what secant graphs look like. So we know that the minimums of our companion pattern turn into the relative or local maximums of our secant graph, whereas the maximums of our companion pattern, so the maximum right here, all those maximums from our companion pattern will turn into the relative or local minimums of our secant curve. So we can go ahead and do that here. We'll put some key points. So this minimum turns into our relative maximum. We know x-intercepts turn into vertical asymptotes. So here you see there's that vertical asymptote we predicted when k was 0. Our maximum of a companion pattern will be our local minimum point. We'll have another vertical asymptote here from that original 0, or that original x-intercept. And that's when k is equal to 1. And then we have another minimum of our companion, so that'll turn into a local maximum. And so you may get to the point where you can kind of recip and sketch at the same time because you know what secant functions look like. And so here is one cycle of our graph. Now we can repeat this for as many cycles as we need, so we'll just keep going for as much space as we have. So we can finish out this curve here. And we know we have another vertical asymptote. Check back with your asymptotes equation. This will be the asymptote when k is 2. We have another curve that has a local minimum here. Another asymptote that happens when k is 3. And another partial curve there. And we can work in the other direction as well. So here we go. Here's our asymptote when k is equal to -1. And we just do this pattern for as much space as we have. Asymptote happens when k is -2. Another curve that has a local maximum. This is the asymptote when k equals -3. Another local minimum. Here's when k is -4. And another partial curve here with a local maximum. So this is 4 cycles of our graph. Do as many as you need. And as you finish up, be sure to take a look at all of your original information, especially that asymptotes equation. Make sure everything makes sense together. I'll post some more examples of worked out secant graphs, as well as some examples of other trig functions. So be sure to check those out, and thanks for watching.